Hey students, in this video we're going to go through section 5.1, which is about ratios and ratio tables. Our learning target is I can understand ratios of rational numbers and use ratio tables to represent equivalent ratios. So starting with vocab, a ratio is a comparison of two quantities. So it just means you're comparing the amount of two different things. Here's two examples. Saying 2 snails to 6 fish. We're comparing the amount of snails to the amount of fish. Maybe it's like in a fish tank or something. Another example, 1/2 cup of milk for every 1/4 cup of cream. This could be a ratio about a recipe, saying in a recipe, this is the amount of milk and this is the amount of cream. That's all a ratio is. It's comparing the amounts of two things. Now, the value of a ratio, A to B, it's like our pretend ratio, any ratio we want, is the number A over B. So it's a fraction where you put your first number in your ratio on top and the second on the bottom, which describes the multiplicative relationship between the quantities in the ratio. It's telling you what can you multiply the second number of your ratio by in order to find the first number in your ratio. So in this one, the value of the ratio is going to tell you if you know how many fish there are, you can multiply the number of fish by this amount, the value of the ratio, to find the number of snails. I know that sounds a little weird, so I'm going to show you both examples to hopefully explain it a little better. So the value of this ratio, 2 snails to 6 fish, is the fraction 2 over 6, first number over second number. And actually, I could simplify this fraction. I could divide both numerator and denominator by 2 to get 1/3. That would be the value of this ratio, 1/3. What does this mean? It means the number of snails is 1/3 the number of fish. So there's less snails than there are fish because the amount of fish there are, 1/3 of that amount is going to be my number of snails. It's saying, hey, if you know there's 6 fish, multiply it by 1/3 and you get 2 snails. So however many fish there are, the number of snails is only 1/3 that amount. Let's write that down. Snails is 1/3 number of fish. That's what the value tells you. This value tells you the first object, the first thing is this amount of the second thing. It's 1/3 of the second thing in this case. Let's try another one. 1/2 cup of milk for every 1/4 cup of cream. So again, value is first number over second number. This is a complex fraction where there's a fraction in the numerator and denominator. Remember that fraction bar means division, so I could rewrite this as 1/2 divided by 1/4. And because it's division, I'm going to keep change flip. Keep 1/2 the same, change to multiplication, flip the second fraction. Could cross cancel the 4 and the 2 by dividing both by 2. I get 2 and 1. And when you multiply straight across the numerator and denominator, you get 2 over 1, or just the number 2. So this one is saying the amount of milk is 2 times the number of cream. They're saying how much cream you have, if you multiply it by 2, you will get the amount of milk you have. So I'm going to write that one down again. It's saying the amount of milk is 2 times the cream. The amount of cream. So again, the value tells you the first number is this amount of the second number. In this one, the number of snails is 1/3 of the number of fish. It's just a portion. In this one, the amount of milk, is 2 times the amount of cream. So we're doubling the amount of cream to get our amount of milk. That's the value tells us. Okay, moving into our first example, you make flubber using the ingredients shown right here. Write the ratio of cold water to glue. So that's just comparing the amount of cold water to the amount of glue. 3/2 cold water to 2 cups glue, just like that. Sorry, that's a 3. It doesn't look that great. Or we could write it like this, 3/2, writing the actual word 2. There's tons of ways to write a ratio. The first one's probably one of the more common. That's just telling us how much cold water there is, how much glue there is. Now we're going to find and interpret the value of the ratio. Remember, the value of the ratio is a fraction where we put the first number on top and the second number on bottom. 3/2 over 2. And again, because this is a complex fraction, that fraction bar right there means division. It means 3/2 divided by 2. And so I'm going to flip this to actually figure out what it's going to be. So keep 3/2, change to multiplication. Flip the second fraction. 2 is 2 over 1. So when you flip it, you get 1/2. There is no cross canceling. So when you multiply straight across the top and bottom, you get 3/4. What does 3/4 mean? Well, remember, this number tells you that the first thing, cold water, is 3/4 the amount of glue. So it means how much glue there is, only 3/4 of that amount represents the amount of water. So there's less water than there is glue because the water is only 3/4 the amount of glue. So that's what I'm going to write. Cold water is 3/4 glue. The amount of cold water there is only 3/4 the amount of glue there is. All right, moving into our second thing. Two ratios that describe the same relationship are equivalent ratios. So for example, saying 1 cat for every 2 dogs or 2 cats for every 4 dogs, right? Both relationships represent there being 1 cat and 2 dogs. They're just different amounts. The first one is only 1 cat and only 2 dogs, and the second one we doubled each one, 2 cats to 4 dogs. The values of equivalent ratios are equivalent. So if I were to go through this process with all my equivalent ratios, the value of each should be equivalent. If you write the value of each ratio, you should get the same number each time. You can find and organize equivalent ratios in a ratio table. It looks like this by adding or subtracting quantities in equivalent ratios or multiplying or dividing each quantity in a ratio by the same number. And I want you to put a star next to the second one because that's the main one we're going to focus on. Because the adding and subtracting can be a little trickier. Multiplying and dividing, in my opinion, is sometimes clearer. It's less likely to make a mistake. So we're going to find the missing values in the ratio table, then write the equivalent ratios. Sorry about the bell right there. So this is comparing the number of cups to the number of quarts. So if there's 3 cups, there's 3/4. I just combined 4 and quarter. If there's 3 cups, there's 3/4 of a quart. But now I want to know, what about 12 cups? Well, to go from 3 to 12, did I multiply or divide? I multiplied, and I multiplied by 4. So I'm going to do the same to the bottom. 3/4 times 4 as well. If I'm multiplying this value by 4, I have to do the same to the bottom to keep it equivalent. 3/4 times 4 over 1. Cross cancel the 4s. Divide them both by 4 so they both become 1. That becomes 3/1, or just the number 3. So that means that when there are 12 cups, there are 3 quarts. All right, what about 15 cups? Well, this time, if you try and look at 12 and go straight to 15, that's a little trickier to do. There isn't a clear number to multiply 12 by and get to 15. But since all the ratios in a table are equivalent, that means I can go from any ratio to any ratio. So I don't need to go from the neighbor to 15. I could back up to 3 and go from 3 to 15. And in my opinion, that's going to be better because I know 3 times 5 is what makes 15. So I'm going to do the same to the bottom. 3/4 times 5. Again, I'm going to do that off to the side. Remember to give it a denominator of 1. 3 times 5 is 15, and 4 times 1 is 4. Now, I know almost all the time I ask you to rewrite something as a mixed number, but oftentimes in ratios, we actually like to use improper fractions instead. So when there are 15 cups, there are 15 quarter quarts, 15 over 4 quarts. And last but not least, I have 5/4 right here. So I can choose a variety, any of these, to go from to get all the way here to 5/4. I'm personally going to choose my 15/4. If I have 15 of something and then all of a sudden I have 5 of that thing, because the denominators are the same, right? 15 of this, 5 of the same thing. How did I go from 15 to 5? I divided by 3. So I'm going to do the same to the top. 15 divided by 3 is 3. So when there are 3, I am so sorry, it is not 3. 15 divided by 3 is not 3, it is 5. Oh my goodness. I was looking at something different. My brain just skipped that. Oh my goodness. Okay. Sorry. 15 divided by 3 makes 5. So 15/4 divided by 3 makes 5/4. Do the same to the top. 15 divided by 3, you get 5. I'm so sorry. My bad. Okay, so all of these ratios are equivalent. They all represent the same relationship. If I were to go through and find the value of all 4 of them, the values would all be the same. The last step, it said, is write the equivalent ratios. We can't forget to do that. Remember, since a ratio is a comparison of 2 different things, that means the 2 numbers, one on top of the other, the cups and the quarts, those 2 different amounts create one ratio. So there are 4 here total. The first is 3 to 3/4. The second is 12 to 3. The third is 15 to 15/4, and the final one is 5 to 5/4. Those are our 4 equivalent ratios. Again, they would all have the same value if you went to do that for every single one.